Okay, this is the part 3 of the lab 9 eBGP lab. So in this video you will learn about configure BGP routing on the ISP. So first of all, similar to the configuration in R1 and R3, you need to configure ISP to become eBGP peers with R1 and R3. So basically what you have to do is issue the command config t router BGP 65002 and then use the neighbor command to establish R1 and R3 as the BGP peers. So the ISP have two neighbors, which is the R1 where the S number is 65001 and R3 in which the S number is 65003. So we need to define the BGP peering for both by using the neighbor command. So what you have to do is you need to identify the next hop address for each of the S number. So 65001 is R1. So the adjacency of the BGP peers, of the neighbors is already enabled and up. So the next is 217 for R3. So now the adjacency of the BGP peers 217 is already up. Now remember that we have removed the static root and default root for R1 and R3 and also the ISP. So to advertise a default root in BGP, because you have already removed it, right? Because why we remove again? Because we want to use the dynamic BGP routing, okay, for connectivities between the sites. Yeah, so you need to advertise a default route in BGP. So what you have to do is you need to add a dummy static route. Okay, if we go to part 3, you have to add a dummy static default route on the ISP. So this will make the 0.0.0 side 0 appear in the routing table, but it's not for forwarding. It's just for default route advertisement. Okay, so I'll issue the command. Make sure you are in global configuration mode. Okay, press exit, type exit and go to the global configuration mode. IP root 0.0.0.0 0.0.0.0 and then the exit interface is null 0. Okay, the exit interface is null 0. So just ignore the warning message. And the next step is we want to advertise the static default route via the BGP. So this command should be issued under the BGP 65002. Okay, so we go back to the the BGP configuration and type network 0.0.0.0. So notice the difference here on R1. So if I go to R1 configuration, so the network that we define here is all of the connected network to R1, but on the ISP, the network that we define here is network 0.0.0.0, not the connected network. So why do we use network 0.0.0 for ISP in BGP? So because here in the small lab, you can manually advertise each connected network like what we have done on R1, which is network 200.200.0, network 200.16. You can actually manually configure that. If you go to some examples outside, some packet tracer example, outside of this class, you can see there are people who manually advertise the connected network. But in this case, because I have already removed the default route on the border router R1 and R3, so by using the default dummy route like what I have done here, IP route 0.0.0, 0.0.0.0, it will allow the ISP router to advertise the default route to its BGP peers, because we need to think and simulate the real world environment. So basically the ISP will have the customer routers. So when you advertise 0.0.0.0 via BGP, it will make the ISP act like a real internet provider, meaning I can handle your unknown traffic. Right, so initially when you use static route, so you use default route because you do not know the destination. But in here, we use network.0.0 by issuing the command. The ISP will advertise all the needed routes to R1 and R3, because you need to understand ISP have so many connected networks in real environment, so that the routers will have R1 and R3 will have the full routing table, which includes the internal LAN network behind the other sites, and also the default route 0.0.0 for all unknown destinations. So this is the reason why I made the configuration in this way. Okay, so as you see here, I want to reiterate, now 0 is actually a virtual interface. So basically when I put here, so there's no forwarding, we just want to advertise the default route, that's it. Okay, so the final configuration of your ISP should look like this one. Okay, so again, I would like to reiterate that you can manually configure the connected network, but in this case, I just want to show how it was done in the real environment, and the propagation of the default route is done by the ISP, not by the border router. Okay, we just want everything to be completely dynamic in the BGP environment. So I'll see you in the next lab to show how do we verify BGP.